Today, uh, I- I'm going to start third lecture of uh, 2024 May June. Paper version is 21, and actually, this is paper 2 of IGCSE physics. Uh, if you have not understand first two lectures of IGCSE physics, May June 2024, 1 to 28 question answer session, then you can look at the right corner of your screen where you will see the I button and click on that button. Then you will easily find out the whole lectures of previous MCQ solution. Okay, I have solved 28 MCQs already, and today I am going to start 29 and 29th MCQs, that is related to the electromagnetism. The diagram shows a solenoid carrying an electric current. This is a solenoid, which shows which row compares the strength of the magnetic field due to the solenoid at point Y, and Z with the strength of magnetic field at point X. The question is that you have to compare the value of magnetic field strength at Y and Z with respect to the X. Okay. First, remember, understand these two columns: magnetic field strength at Y and magnetic field strength at Z. You have to compare both the field with X. Remember that in magnetic field, in solenoid, inside the magnetic field lines are parallel and uniform and strong. Okay. If you look on these lines which I'm drawing here, this is the electric field line inside the solenoid. And if you look at this portion, remember the magnetic field line outside the solenoid is very weak as compared to inside. That is why we can say that the strength of magnetic field at X and Y is similar, because both are in same line and inside the solenoid. And at Z, the Z point is outside the solenoid, so we can say that the strength at Z will be lower as compared to X. Okay, so look at the option. Magnetic field strength at Y is equal to X. Yes, equal to X. And magnetic field strength at Z less than X. Yes, because at Z it is weaker than at X. So first option is correct. Okay, understand? It is very easy question. Now, second question is 30th question is, this question is very important, and you can understand it if you have little bit idea of Faraday's flaming left hand rule. I will see the picture on the Google also. First of all, you have to understand the question. The question is that a conducting wire is placed between the poles of a magnet. You can see this is the conducting wire. The arrow sign is showing the direction of the current is vertically downward, and when electric current is in the wire is in the direction shown, then the core force on the wire acts out of the page. It may he is giving you a hint that when current is flowing in downward direction through that wire, the direction of magnetic field line is from north to south. It are always from north to south. Okay. And uh, three statement of different conditions and how the wire is affected are given. Here are three different conditions are given, and you have to understand which one is correct and which one is wrong. Then you have to finalize your answer. First option is that before you understand these 3 points, I want to show something from the Google side, that is flaming left hand rule. According to flaming left hand rule, uh, this is the flaming left hand rule. Okay, only I will. I'm taking this one. You have to stretch your thumb, first finger, and middle finger in this way that your first finger should be in the direction of the magnetic field, and middle finger in the direction of the current, and then thumb will indicate the direction of the force acting on the wire. Okay, this is the rule of flaming left hand, and this is also yes, remember, you can check this diagram. This is the north pole, and south pole magnetic field is coming out from the north and entering into the south. Then he has stretched his first finger in the direction of magnetic field, and current is flowing in that direction, and he has stretched his middle finger in the direction of the current. Then thumb indicate that the magnetic force will act in vertical upward direction. As a result, the wire will start to move in upward direction. Remember, if you change any one direction of current or magnetic field, I am repeating here, if you changed any one direction, either you are changing only direction of magnetic field and current is in the same direction of, then the direction of the force will be reversed. Okay, uh, it will be now downward direction. In second case is that if you are keeping the direction of magnetic field same and change the direction of the current, uh, mean to say you are changing the direction of current in backward direction, then force will be in, for the direction of force will be reversed. This is the second case. If you are changing all parameter or all the direction, mean to say you are changing the direction of magnetic field in the same way you are changing the direction of the current, then in both you are making a change with two parameters simultaneously, then direction will not be changed. Okay, this is the 3 points I have told you. Now we are going to check which option he yes. First option is that uh, when the current is towards the top of the page, current is towards the top of the page, the direction of magnetic field unchanged, the force produced act into the page. Yes, if you look at that, the current is in downward direction and the magnetic field is north to south and force acting out of the page. Here he has given first option is that the you are changing the direction from bottom to top of the current. Direction of magnetic field unchanged, then direction of force acting on the wire will be out of the page, into the page, and this one is out of the page. So direction of force will be reversed. This is correct option. When the current is towards the bottom of the page, it means you are not changing the direction of the current, and you are changing only the magnetic field. It means now north will be here, south will be here, direction of magnetic will be reversed, then force will be into the way. Yes, this is correct. I have already told you that if you change any one parameter, then direction of force will be reversed. Both are correct option. Third one is when the current is in the wire is alternating, and this is the direct current. Here he is saying that now the current in the wire is alternating. Alternating current is that whose direction is changing in equal interval of time. Okay, the wire vibrate into and out of the bed. Yes, this is correct. It means all the options are correct. So our first option will be correct. I have give you all idea of the of this question. Now move towards the third one. Which type of electric current in the primary and the secondary coil of the step up transformer? Remember that step transformer always used to change the alternating current. Second definition of this transformer is that we can increase or decrease the value of alternating current. transformer does not work on DC current. So the option that is related with DC are all wrong. And I will mention here DC wrong. This is DC wrong. And this is also DC. So these three options are wrong. Only first option is correct. Both are AC. Yes, it converts alternating current and into alternating current. Primary coil is that the current which we are supplying to the transformer. Secondary coil is that by which we get output. So input and output are in alternating current. Now, next is before we are going to the next question. Kindly subscribe this channel for daily based updates. Okay, and 32 32 question is that a scientist fires alpha particles at a very thin sheet of the gold and detects the particles that passes through. Which statement about the result of the scattering experiment is correct? Basically, this question is related to the Rutherford experiment, I think. Okay, Rutherford, I will show you the little bit information about Rutherford experiment so that you can easily get goal for. Yes, you can see. I will give you this one. Look at that diagram. Rutherford falls alpha particles on the thin sheet of gold foil. You can check if I open into the next tab, you will see the clear. Just wait. Yes, this is the correct one. Now you can see Rutherford did this experiment. As you can see that when alpha particles are falls out on the gold foil, this is a very thin sheet of the gold, and you can see when these alpha particles collides with the central part, which is very dense of part of the atom, to whom Rutherford called is nucleus. Uh, the charge on alpha particle is positive. Remember, I am repeating that the charge on alpha particles is positive. When these positive rays are moving towards the gold foil, some of the beams is deflected with large angle. This shows that the charge on the nucleus is also positive. The positive charge will repel the positive charge alpha rays, and most of the rays is coming out from the gold foil. It suggests that most of the part of the foil or atom is empty. That is why a maximum number of alpha rays are moving without any deflection and moving in straight path, and little bit are deflected in large angle, and some only few one is deflected back or are bouncing back in the same direction as you can see in that diagram. Okay, this is a little bit idea of that question. So you can check alpha particle are attracted to the nucleus. No, nucleus cannot attract the alpha particle because both have same charge. They can repel. Okay, this option is wrong. Half the mass of the atom is concentrated in the nucleus. No, this is the wrong. Half mass of no, this is not related to the experiment. Most of the alpha particles are deflected, showing that nucleus is very dense. I think it is correct. Only a small number of alpha particles are deflected, but some of these are deflected through large angle. I think D option will be the correct. I have to check the answer. 32 is D. Yes, you can see only small number of particles are deflected, and some of them are deflected through large angle. You can see this one. This is a large angle. This is deflected back, and maximum number of alpha rays are passing without any deflection. Next is, so D option will be your correct answer. Is it clear? Now move towards the next question. uh, it is a very easy question. The neutron, the notation represents the nucleus of a gold atom. This is the symbol of gold, and 197 is the atomic mass or mass number of the gold atom, and 79 is the atomic number. It is also called proton number. The relative charge on the proton is +1. What is the relative charge on the gold nucleus? Remember, there are 79 proton, so the charge on the proton will be 79, because one charge on one proton is +1 and charge on 79 proton will be 79. It is very simple question, easiest question. So your option is A. Now move towards next. uh, an isotope of hydrogen has the nuclide notation is, isotopes mean hydrogen atom has three isotopes, and this is one of them. This is deuterium, because it has the atomic mass of this isotope is 2. How many neutrons are there in nucleus of this isotope, and what is the relative charge on the nucleus? It is very simple. uh, from you have to When you have to find the neutron number, you have to subtract proton number from the atomic mass. I will solve it in front of you, then you can easily understand what I want to say to you. Atomic mass is equal to proton number plus neutron number. Atomic mass, it has given to you 2. You can see this one, and 2 is equal to proton number is 1. You have to find neutron number. Yes, 1 will be less in left hand side. Okay, so your answer is 1. Number of neutrons is 1, and relative charge, how many neutrons are in the nucleus of this isotopes, and what is the relative charge on the nucleus? Okay, a neutron has no charge. The hydrogen has 1 proton, so relative charge will be +1. Number of neutron is 1. You have to find this, so our option is 1. So you have to understand the basic points, basic key points of each question, then you can easily solve all this question. Understand? Is this is related to the radiations, and you can solve it if you have little bit idea of the properties of alpha, beta, and gamma radiation. Okay, I will give you little bit information about that. Alpha particles are less energetic as compared to gamma. No, you can understand in another point of view is that the ability of alpha particle is that it is more ionizing. It has more ionizing ability. Beta particle has less ionizing ability. Gamma particle has you can say has no ability of ionizing the atom. But if you look on the penetration ability, alpha particles can be stopped by sheet of paper. It cannot pass the sheet of paper. Beta particle can pass out from sheet of paper and can be stopped by the aluminium sheet. And but if you look on the gamma radiation have ability to pass out paper sheet and aluminium sheet, and it can be absorbed by boron or lead block. Okay, now you can understand the question easily. Then you can easily understand, give the answer of that question. It is very easy. A radioactive, because I have given you the hint of that question. A radioactive source is placed near the detector. This is the radioactive source from which different types of radiations are coming out, and material placed here, and this is the detector. The detector can detect the radiations coming from that radioactive source. The radiations arriving at the detector from the source is measured for 10 minutes with different material placed between the source and the detector. Uh, this is the source which he has written here. None mean initially there is no material between detector and the radioactive source, and then they place the paper of sheet, then thin sheet of aluminium, then thin sheet of lead. Okay, I have to scroll a little bit more. Yes, you have which type of radiations are emitting by the source. This is the data. You can see when there is no material between the source and the detector, the radiation counted by the detector is 5626. When it placed a sheet of paper, and then it mean uh, the detector counts 5629, little bit more. I think it detects the background radiation also. If you look at this one, when they place the thick sheet of aluminium between detector and source, then detector counts 2226. It means radiation are more than half radiation are stopped uh, by the uh, by the aluminum sheet, and rest of the radiations are coming out and detected by this detector. The thick sheet of lead, it means when you place the thick sheet of lead, and again detector detect 255 radiation. So you have to identify which type of radiations are coming out from the source. So I have already told that if you see alpha particle, it will be wrong. The reason is that alpha, when you place paper of sheet, detector again detect the radiation. It means it is not the source is not emitting alpha particle, and so we have only two options. If you look on D option, beta particles only, so it means if you place the beta particles only, then they cannot pass out the thin sheet of lead, because the detector are again detecting 255. It means beta particle not only, because beta particle uh, can be stored by this one, but if you look on the gamma radiation, it means you are using the source is emitting two types of radiation, beta particles and gamma rays also, because gamma rays moves from sheet of paper, thin sheet of paper, and little bit from this one to gamma is correct. If you look on the beta particles can pass out uh, sheet of paper and can be stored by this one. That is why we are selecting beta particles is here. Okay, if you alpha particle cannot pass the sheet of the paper. Okay, they can be absorbed by the sheet of paper, and then the counter will show the zero here. That is why alpha particle is not emitted by the source. So these are the main reason. So your option will be C only. Now this question is very important, because if you look on the paper 4 of theory, and for A levels paper 2, this question is also asked in theory question also. Okay, theory paper, sorry, theory paper. This question is asked in theory paper. The reading on the detector placed near radioactive material is 536 count per second. It means detector is detecting the 536 counts per second. The background means the radiation coming from the atmosphere and from your surrounding from different materials, and is 44 count. So when you have to find the accounts remaining count, then you have to subtract background radiation from the radiation counted by the counter. So in that case, first of all you have to remove the find the actual number of count. Radiations you can also write radiation. Okay, total was 536, 536 minus 44. Answer is, I have to use the calculator, and 536 536 minus 44, 492. It means 492 is the actual counts that is emitted by the radioactive material. Okay, the half life of the radioactive material is 34 hours. It means half of the atoms is this can be destroyed in 34 hours. And what is the reading on the detector after 68 hours? It means you have it is the second half life. Then you have to find the remaining number of atoms after second half life. So formula is that uh, at remaining number of counts is equal to total counts divided by power of 2, or power of 2. I will write here n. You can, I will write with the lead pencil here. The power of n is equal to 2. So the power of 2 is n. This is n. Here n represents the half-life. The question is that you have to find the reading after second half. So you have to put the value of n should be here. N is equal to 2. Then total count, you have total count 492. 492 divided by 2, and power of 2 is 2. You have to place the value of n is equal to 2 here. Okay, next, the power of the 492 is equal to 492 divided by the square of 2 is 4, and you have to divide this one. 492 divided by 4, 123. So your answer will be 123 counts. B option is the correct answer. Okay, if you did not subtract count, background count, then your answer will be wrong. Okay, so you have to check the background radiations also. Now moving towards the uh, space physics. This is interesting. A planet in the solar system is at the point in its orbit where it is closest to the sun. Which row is correct? Remember that you have to understand the solar system, the orbit in which planets are revolving around the sun is not completely in circular path. It is elliptical orbit. So center is not sun is not at the center of the solar system. Sun is little bit on one side. I will show you that this is the sun, and your orbit will be just like that. Okay, the planet is revolving in this orbit. Suppose that this is the planet. Remember, when this is the sun, and this is the planet P. I will write here P. Okay, which row is correct? Orbital speed and gravitational potential energy. Remember, if you see the definition of gravitational potential energy, when any object get the energy possessed by a body due to some position or some height, then it will have gravitational potential energy. If you understand the last chapter of the space physics, where I have read that when the planet is far away from the sun, just like here, at that point, its potential energy is maximum, and kinetic energy will be lower. It means it is moving with slow speed. On the question is to identify which statement is correct. When the planet is close to the sun, its orbital speed will be maximum and potential energy will be minimum. This is the combination. Okay, so you orbital speed is maximum and gravitational potential energy is minimum. So this is the B option which you have to correct here. Remember, if you say orbital speed maximum at close to the sun, it means its kinetic energy is maximum, because the formula of kinetic energy is 1 by 2 mv square. V is the speed of the object. That is why kinetic energy is maximum. So next is, what is the main process that powers the sun? This is very simple question. How the sun is producing a light from billions of years free of cost. Burning of helium and oxygen, no. Burning of hydrogen and oxygen, no. Nuclear fusion, yes, of the hydrogen to form helium, yes. On the surface of the sun, only nuclear fusion reaction are existing, in which light nuclei combine to make a large nuclei. Light nuclei is hydrogen that make helium atom. This is a big atom. Okay, so this option is correct. If you see on the last option, nuclear fission reaction, no, fission reaction is not possible, because in fission reaction, we bombard in fission reaction uranium. When we bombard the slow moving neutron on the uranium atom, then uranium atoms split into small daughter nuclei. That's why this is not the correct option. Only high, the reason is that the core and the structure of sun is made by maximum number of availability of hydrogen atoms. Okay, now so your option will be C. Okay, uh, this is second last question. I think this is related to the Hubble's law. Hubble's law is very important. I will give you the definition of Hubble's law also. Galaxy is 3 multiplied by 10 raised to the power 20 kilometer from the Earth. At which speed is the galaxy moving away from the Earth? So I will solve here. Remember, Hubble's law says that uh, V is equal to HD, H and D, where H is the Hubble constant and D is the distance of galaxies from the Earth, and V is the speed of galaxy with which galaxy is moving away from the Earth. So Hubble says that the speed of moving galaxy with which it is moving away from the Earth is directly proportional to the distance of the galaxy from the Earth. So H here, H is the Hubble constant. So the value of Hubble constant is 2.2 into 10 raised to the power around 10 raised to the power minus 18. I will write in power minus 18. Okay, and the distance D is given 3 multiplied by 10 raised to the power 20. Okay, 10 raised to the power 20. So multiply 3 multiply by 2.2 and 3 multiplied by 2.2 is, it will be 6.6, and multiply by 10 raised to the minus 22 and 20, it will be equal to 10 की power 10 raised to the power 2, it which is equal to 100. So multiply this one, you will get 660 kilometer per second. Okay, So our option will be this one. Remember, this is the distance in kilometer. So you have to select the option in kilometer, not in meter per second. Is it clear? Okay, last option is MCQs is it is very deep MCQs of paper 21 of 2024. Uh, an astronomer observed a distant galaxy. The table shows how the distance and the speed of recession of the galaxy are determined, which row is correct. So you have to give the little bit idea how we can find the distance of the galaxy and speed of recession. Speed of recession means the speed by which galaxy is moving from us. Remember, our space is expanding on daily basis. That is why galaxies. It means galaxies is expanding. The galaxy is moving away from the Earth. That is why we are using here the word of speed of recession. Brightness of a supernova in a galaxy and change in the wavelength of starlight from the galaxy. Remember, first option is correct. The reason is that uh, Doppler gives the idea of light coming from the distant galaxy. Doppler says that the light coming from the galaxy starts to convert into the red region of visible light. It means red shift. This is the evidence of this is the evidence of galaxy is moving away from the Earth. So this side is correct. On the other hand, if you look on the distance, bright depends upon the brightness of supernova in the galaxy. This brightness shows that how much energy is coming out from the stars or galaxy in 1 second to the Earth. That is called the luminosity, which is related to the brightness of a supernova. Because when supernova basically the stage of the star when it is going to the death period or end period of the star, then it converts into the black hole also. Okay, supernova stage is the stage of biggest star as compared to the smallest star. Okay, so your first option is correct. I have give you all detail of all question. Now we will in coming video I will give you detail of paper 20, P22 version MCQs of 2024, and then you will easily. I will also upload the topical past papers also of last 8 to 10 years, and lectures will also be uploaded in detail where you will find out the key points to solve the past paper. Okay, Allah Hafiz. Stop.